So Ruchira will tell you that is what is the study and other things. Before that, I am giving you the general idea about how to do the R. Okay. So Ruchira will tell you that is what is the study and other things. Before that, I am giving you Stop share. I think this is visible to all of you. So this is the hello. Hello, am I audible?
Yes, sir.
Yes, sir.
Audible.
Yes, sir, audible.
Thank you. So dim means dimension. So dim indicates that is how many rows and how many columns. And H is the vector. Ruchira already told you what is called the vector. So this is a vector, H is the vector, H is the variable. The vector includes several elements. So all the elements, they are in this vector. If you have any query, please you ask me so that I can help you. And if I want to know what is the data, then I can write down view ACH. So here you can find out that is just like the Excel sheet. Okay. So we have imported this data from the Excel to the R. And if you want to know more about, then you can write down edit SEH. Is it visible?
Yes, sir.
Yes, sir. Visible.
Visible.
Okay, so here you can edit. For example, it is 3 written. So you can change this data 5. Okay, so like that. But it will not be saved because you have not created any vector. So if you created the H equal to edit, then bracket H, that is H means that is a vector. Then automatically it will be stored. But we do not want to store this data because it is a, for that reason, we are not using this data. So again, I'm going to the H. Okay, so there is no change. Now, here I am writing str in bracket SEH. So you will get the structure. Okay, so this is the structure. So you will get the 9 variables and all the variable has the integer. Okay, and total 209 observations are there. 9 variables are there. So this is the data and that is from 1 to 5 rating scale. All the scale, this scale is the rating scale. Okay. Yeah, these are the rating scale. Okay, now I am requesting Ruchira to tell about the study, about the specific study from which I have done it. So Ruchira, please.
Yes, sir. Can you see the slide, study on norm estimation?
Yes, ma'am.
Okay. So, a study was conducted by SIR, where the objective was to estimate the norm on achievement motivation of personnel in a microfinance company. Achievement motivation is a motive in connection with evaluated performance in which competition with a standard of excellence was paramount. In microfinance service organizations, CFR, people tend to compete in terms of number of customers, clients, and amounts of loan. In achievement motivation, we studied career impact, problem solving, hard work, uncertainty, and problem thinking. So these were the subtopics that were studied under the achievement motivation: career impact, problem solving, hard work, uncertainty, and problem thinking. The method, now we move on to the method where data was collected from 284 employees of a microfinance company in India through call center. So a 5-point rating scale with 30 items measuring achievement motivation was administered. After item analysis, 9 items were selected for the final scale. Okay, and for that reason, when Sir showed you the our screen, there you could see that there were 9 items. Okay, so out of 30 items, 9 were selected for the final scale. These items are: I am interested in how my contribution impacts my career. I am eager to learn and enjoy developing new strategies. When confronted with complex problems, I like to look for new solutions. I often feel the drive to achieve something. When I cannot do something I really want to, I think about why I fail and try again. I have a strong desire for feedback on my performance. I like it when people say in front of others that I am doing a good job. I regularly list my goals where I can see them during the day. I feel motivated to do better when someone else is better than me. Okay, so we are measuring the achievement motivation of the persons working in a microfinance company. Okay, for the selection of further future personas, we had to develop this norm for the achievement motivation. Okay. The 5-point rating scale categories were strongly disagree, disagree, undecided, agree, and strongly agree. The mean of achievement motivation is 0.84 and the SD is 4.91. The Cronbach's alpha, which is the internal consistency reliability, is 0.84. Okay. Acha. The mean. Okay, so this is the study. There has been error in typing. The mean of achievement motivation will be slightly different. I'll check and get back to you all. While the Cronbach's alpha internal consistency reliability is 0.84. Okay. Now we'll start with correlation coefficient that Sir will explain to you how to do it in our for norm estimation. Okay, and before starting, these are the steps of norm estimation of summated rating scale. First, we have to find the correlation coefficient. Then we have to move on to item analysis, then standard score or Z score, then T score, and then classifications of individuals. Okay, so I ask Sir, hand over to Sir to start the presentation.
Thank you, Ruchira. Now again, I am going to the art studio. So the first part that this Likert type scale is a summated rating scale. What does it mean? That means all the items. Is it visible to all of you? Hello?
Yes, sir.
If the items are visible to all of you? Okay. So what is important, that is I have to find out the sum by the row. So how many sums will be there? 200 sums, 209 sums. Okay, because 209 observations are there. Is it clear to all of you? Okay. So now what I will do, here I am writing H total. So H total is the vector. I am creating this vector. It is called the H total. So APPLY, apply. Apply is the function. Then H. H means this data frame. Okay. Okay, before that, I like to share that is what is called the data frame. So if I write down class, bracket H, so you will get that is the H is the data frame. Okay. Why it is data frame? Because multiple variables are in this particular vector. Okay, so H is the vector and the vector type is the data frame vector. Is it clear to all of you? So now, what is my function? I have to calculate the item total correlation. That means 9 variables are there. So 9 items are there and 209 observations are there. Okay. So I have to find out the sum of 209 observations. How I can get it? So I can create one vector H total equal to apply, then bracket H, comma 1, comma sum. Okay. So 1 indicates row, 2 indicates column. Okay. Now, if I want to know that is what is in H total, I can write down paste. Is it visible to all of you? So you will get that is a 209 observations are there. Okay. So this is the total score. This is the total score. So what is written? 1 equal to 33. So if I go to the first data, then if you add this first row, then you will get the 33. Again, if you add this, then you will get the 32, like that. So this is the total score by the row. So next, I am creating another vector, H code equal to COR bracket ACH. ACH means these 9 items, comma H total. Okay. Then if I write down paste, Okay. So I will get the correlation, H code. So 9 items are there. And each item is correlated with the total score. So first item correlation is 0.85. Next 0.88. Third one this, fourth one this, and fifth one this. So if I want to find out okay, so this is the from lowest to highest. Is it clear?
I have a couple of doubts.
Hello? Yes.
Hello. Yeah, I have a couple of doubts. First one is when you defined H core, it was a small letter, right? ACHCOR. But
Yeah.
when you pasted H core, it's a different variable, right? The vector. And also, why are we correlating it?
H code means it is the correlation.
Yeah. What
Okay.
I'm asking is both one is everything is in small letter, and the second one is the C for the correlation COR, it's in capital letter. So those are two different variables, right?
এটা কি capital letter? Let's not get a chance. Okay. I'm showing you.
And the second thing is, why did you to calculate the correlation? Why did you do H core and H total? And also, why did we get 5 values only?
Okay, because the content validity, you have to test it. So content validity, for that reason, item total correlation is important. So whenever you want to design any questionnaire, particularly the rating type, summated rating scale, then you have to show the content validity of the questionnaire. So when you do the item total correlation, then you will get this data. Okay.
So it is item to item total correlation.
If you want to know the item correlation, then that will be different. But here I am talking about the item total correlation.
Okay.
Okay, it is not the item correlation. If I write down COR in bracket ACH, so this is the item correlation. Is it clear?
Yeah.
Okay. And you are talking about this capital and small, because this is a vector. Okay. And here I have written H code, but previously I have used another H code, and there it is the capital. So this is a vector issue. It is nothing more than that. But the only thing that is they can recognize easily. So if you write down the small or capital, that is not the issue. Issue is there is a vector, name should be the same. Otherwise, because this H code and this H code, this small H code and this suddenly this C capital, these are both data are same.
Okay.
Yeah.
So
this is basically the item correlation.
Yeah, I understood the item correlation, but I can't get the item and item total correlation because we are getting only 5 values, right?
5 values now. 1, 2, 3, 4.
Right.
Acha, 5 values are actually. Why 5 direction? Oh, 9 values are there. Okay.
Yeah.
I'll show you.
Yeah.
Okay, one sec. What is the H code? Okay, so now this is the, I think 9 values are there. Okay.
Yeah.
So 9 values now are available. Okay. So that means this is basically the item total correlation. And the other one is the, yes, item correlation. Okay, so this is the very important issue, specifically in case of the item analysis. Now I am going to this one. Now I am sharing the screen. So this is, I think, visible to all of you. There is a correlation coefficient. Correlation coefficient, you know, it is a descriptive statistics used to measure the relationship or association between two or more variables. Okay, but correlation coefficient will be inferential statistics when you will deal with the inference for the population. That is whether it is significant or not. Otherwise, you can use it only as the descriptive statistics. It indicates the change in one variable accompanied by changes in the other variable. So there is a change of the two variables. However, correlation coefficient does not state the cause and effect relationship between the variables. It only indicates the direction and magnitude of change between the variables. A positive correlation, so there is a positive correlation, indicates that increase or decrease in one variable is related to simultaneously increase or decrease in other variable. And the negative correlation indicates that when values of one variable increases, the value of another variable decreases. A perfect correlation is denoted by the value 1 and no correlation between the values is denoted by 0. The range of correlation coefficient is -1 to 0 and 0 to +1 or -1 to +1. I think this is better. Okay. Okay, now I am requesting Ruchira to talk about the item analysis.
Okay, so after the classification, after the classification of items belonging to the item pool and writing of the items, they undergo a process known as item analysis. Means that first, before formulating a questionnaire, we have to write down or collect a pool of items. There should be a large number of items. Then from that item pool, we select the items, and after classifying those items, we write those items for the final scale, right? So after that, they undergo a process known as item analysis. It is a process by which response to individual test items is examined in order to assess the quality of those items and of the test as a whole. Item analysis is done so that the quality of the those items selected can be assessed, and as well as of the whole test as well. Quality of the whole test is assessed as well via item analysis. It is useful in improving or modifying items for their future use in the test, as well as eliminating misleading or ambiguous items after single administration of the test. So for these reasons, item analysis is very much important to eliminate misleading or ambiguous items or modifying the items which might not be correct in the first go. Item analysis is used to examine two common item characteristics, namely item difficulty and item discrimination.
I think now it is clear to all of you. So the first part, again, I'm going to this art studio. Okay, I have the data. I'm creating another vector, h1 equal to h. So if I write down the h1 only, so there is a first column. So when I am writing h1 equal to h, then this box bracket 1, that means it will be the first column data. So if I write down paste h1, this is visible to all of you. So this is the first column. Okay.
Yes, sir.
Now what is important, that is we have to test the individual difference, okay, in the response pattern. So this is the data that we received. After that, we can write down H table, sorry, H1 table. So whatever comes to your mind, you can make this vector. I'm just writing this one, that's all. So I can write down table in bracket H1. So what is in there? So this is the observation. Is it clear to all of you? So that means the data is very much skewed in nature. Okay, it is very much skewed in nature. Majority 4 and 5, they assigned 4 and 5, and less in 1 and 2, 3, etc. Okay. So now another important part. So what is the assumption? The assumption is that if the item does not vary, okay, with the individual difference, that means that item will not be accepted for the analysis. Why? Because the total data is, if we can find out the sum, so 209 total data is there. So if I think 209 divided by 5 categories are there. Okay, so 41.8, that is the observation. That is the expected data. Okay. So this is the observed data, 3, 11, 25, 76, and 94. This is the observed data. And this is the expected data, 41.8. So now we have to do this analysis, that chi-square test bracket ACH1 table. Okay. So here we find that is a chi-square value for the first item is 158.63 and DAP is 4. Why? Because 5 minus 1 means 4. And this is the p-value. Okay, so this is very highly significant. Highly significant means the individual difference is there. So we have to calculate the individual difference for each item. This is important before going to assess the item difficulty or item discrimination. Okay. Now, if I want to know more about it, suppose I am writing H1 chi, then I can get the attributes. Okay. So this is the observed data. This is the expected data. Is it clear to all of you? Why 41.8? I have shown you. That is, I have collected data from 209 people. So if we think about the equal probability hypothesis, then the observation will be the 41.8. Okay, so that is the expected value. Now, if I want to know more about it, so this is the residual value. Okay. That means again, so this is the parameter already discussed. So what we have noted, that is the first item, the chi-square is 158.63. Now, if I want to know, that is the whether this item's difference is same for the another item, then again we can do the same thing. SEH2 equal to ACH, then I can take only the second item. And then I can write down ACH chi, no, ACH 2 table. Because I want to know the frequency. So now I get the frequency. What is the frequency? Frequency is this one. Again, it is also the skewness. Skewness is there. Okay. Therefore, it is better not to use the other parametric test. We can use the non-parametric tests. That is a better one. Now, if I want to know more about it, that is whether is there any association between the first and second, then we can do the chi-square test. Then the H. H1. H1 table value, comma, ACH2 table value. Okay, so we find that is there is no significant difference. That means these two items are very much related to each other, which is very much expected. Okay. So these things is very important when you want to do the summated rating scale and specifically when there is a high probability that your data does not follow the normal distribution. So you can do the bar plot, or you can do the pie chart by using ACH1. So you will get the pie chart. And if you want to compare the two data, then you can write down par Is it clear to all of you? Okay. So again, you will get the total data. So what you have noted, that is the achievement 1 and achievement 2, they are highly related with each other. So what does it mean? That means they are assessing the same construct. Therefore, you do not find any significant difference in the frequency distribution of the observed data of this pie chart, this achievement 1 item and achievement 2 item. I think this is clear to all of you. Is it clear? Any question?
No, sir.
Thank you, Gorima, for feedback. Okay, now I am presenting you the data, another data. This is another chart I am presenting you. You can write down plot. Plot. Then A C H 1. Total. Okay, so this is the distribution. Change. I think this is visible to all of you. So from this is the total data. This 209 data, this total data is here. You can show this total data. So during your PhD thesis, in the appendix, you can show the total data of your distribution, or you can show this data. Okay, so this is another data. And based upon this data, you can tell that is whether your data is following the normal distribution or not. Okay. This is also possible by showing that is okay. I have used the chi-square statistics, or I have used the non-parametric statistics. The reason is this. Now, one important issue is that when your sample size is very large, then there is a high probability that your statistical results may be similar to the parametric statistical results also. So sometimes people are taking the large data and they are doing the parametric statistics. Okay. Oh. Now, another important part is the classification of the total test score. Okay, because you have to classify the total data. Please you follow. That this is the vector H total. Okay, that is the total score. 209 data were there. That is the total data. And based upon the mean or median, the two dispersions are there. So it is called the breaks equal to 2. And the score below the median, they will be categorized as the low. And the score above the median, those respondents will be categorized as the high achiever. So this is the low achiever and this is the high achiever. We can get this information from the H cut. So if I write down okay, so we find that is the in our respondents, majority people are from the high achiever and few that is the low achiever. I think this is clear to all of you. এটা দেখাচ্ছে এটা দেখাচ্ছে Is it visible to all of you? Hello.
Yes, sir. Visible.
Okay. So this is the Stemley plot. I'm just writing the stem H total. So this is the Stemley plot. And This is the categorization of the total data, low group and the high group. And this is the plot of the data, that is the distribution of the data. For example, here I want to know what is the mean. So mean is 36.70. That means mean falls here. Okay. And if I want to find out the total data distribution by the quartile and the minimum maximum, I can write down 5 num. Okay. That means the minimum score is 16, maximum score is 44. So this is the data, 5 num. And this is the first quartile, this is the second quartile, this is the third quartile. And this is the maximum, this is the minimum. Very good. That's the standard score. Okay, now Ruchira will take the class. So Ruchira will talk about how to design the norm. And then I will show in the art studio.
Is the standard score slide visible?
Yes, ma'am.
Okay. So after the item analysis has been done, which has been explained by Sir, then we have to, for norm construction, the next step is to convert the raw scores into the standard scores or the Z scores. Okay. We all know how to find out the Z score, that is Z equal to X minus mean by SD. Okay. So I'll just go through the write-up ones. As stated earlier, the raw scores obtained by individuals on different ability or achievement tests is quite insufficient to make inter-individual or intra-individual comparisons. However, if these raw scores are transformed into scores of relatives meanings or a scale of common measure, the comparisons can be done. Standard scores are the most common and frequently used derived or transformed scores used in psychological and educational researches. The standard about standard score is that it has a fixed mean and SD. In a distribution, the deviation of the scores from its mean expressed in sigma units are called standard scores. They are also referred to as Z scores. A standard score of any raw score tells us where and how far above or below the mean the particular score lies in the distribution. Okay. So, for this data, now we are going to compute the standard score, okay, in RStudio. I'll just share the screen. So if we use the command, first we have to make a vector.
Scale attribute anta kuda. Scale attribute anta kuda. Leadership for RCB running.
Is our studio visible, right?
Yes, ma'am.
Okay. So now for the standard score, we have to first create a vector. So let's name it as
Scale. CH scale.
ACH scale. Okay,
Equal to scale.
equal to scale. Okay, so this is a vector that I've created, ACH scale, for the standard score, for the transformation of raw scores into standard score. And if we use the command scale and then put the vector, then we can easily get the standard scores. Okay. Now, if you can see, so we have received the
Standard score.
we have received, if I go up, this is the standard score of all the individuals. Okay. Huh.
For the 9 items.
For the 9 items and individual.
9 items.
For the 9 items, these are the raw scores. So the command that we use for transforming raw score into standard score is scale. We don't have to do all the calculations like x minus m by sd. We can just write scale and put the vector, and we are good to go. Okay. So this is the standard score, but as you can see that there are many minus values present in standard score. Okay. So after the computation of standard score, the next step is the computation of t-scores. T-scores, we all know that it is another form of derived score, another kind of derived score, which will be used in norm construction. Can you see the T-score slide?
No, ma'am, it's still our studio.
Okay. So T-score. This T-scale was first derived and used by William A. McTell. He defined T-scores as normalized standard score converted into a distribution with a mean of 50 and SD, a sigma of 10. In scales using Z-score, the mean of the distribution is 0 and the unit of measurement is 1 SD. The use of unit of measurement or 1 SD may carry decimal points and traveling from 0 to both sides of the scale may involve plus and minus signs. As we have seen that there were lots of negative signs as well in our data in the standard score. Hence, in order to remove such limitations, the T-scale may be used. Okay. In the scale of measurement for T-scores, the starting point 0 is placed 5 SD below the mean and the finishing point 100 is placed 5 SD above the mean. Okay. So the T-scale ranges from 0 to 100 with a mean of 50. Its unit of measurement is T, which is 0.1 of SD, and SD here, sigma here, has the value of 10. Okay. The conversion of raw score into T-score can be done with the help of the following formula. T equal to 10 Z plus 50, where Z is our standard score. So computing T-score then for norms becomes very easy. Now, if we write T H, this is a vector that I'm creating, equal to 10 into what was that? At scale. This vector has my standard score. So I'm writing that plus 50. Now, if you see, you will get the T-scores. See, The conversion has been done and there are no negative points. Everything has come into positive. Okay, the minuses are gone. So now comes so after standard score and then T-score, we move on to the classification of the T-scores. Now we have to classify the T-scores. Okay, the and this classification, for the classification of the T-scores, we have to follow a standard classification, for which we have used this classification. 25 to 34 will be very low, 35 to 44 will be low, 44 to 45 average, 55 to 65 high, and 66 and above very high. Okay, on the basis of this classification, we will classify the T-scores now. Okay. So, classify H as a vector that I'm creating is equal to cut, then what's the TH equal to C and I'm writing infinity, that's 66 and above. Okay, for that we use infinity.
Double inverted comma, very low, moderate, above average, outside.
So in this way, I am breaking the T-scores in this range, 25 to 35, 35 to 45, and it goes on, and we are labeling it as very low, low, average, high, very high. Now, if you see,
Classical.
Table,
classical.
না এটা পুরোটা দেখো
আগে রাখতে লেখো কতজন ভাগ হয়ে গেল টেবিল লেখো
so this is the entire classification. Okay,
so each individual is classified. That is low achiever or high achiever.
So each individual is classified as low achiever or high achiever or average. Okay, as per this classification, 25 to 35 and this. Okay. So after classifying the T-scores, the next step is the classification of the range. Okay, classification of the range of the total score. Okay, this is the classification of T-score. With this command, we classified it. Now we will move on to classification of the range of the total score. So the total score will have a particular range, right? So the lowest score would be what? It will be 9 because there are 9 items, and the highest will be 45 because 9 5s are 45, right? So that will be the range. So for now, we are going to find out the range in R. Okay. Suppose I am naming it as H range equal to 9 is to 45. So the range has been given. Okay. Now we are going to find out these, right, the standard score of the range, the numbers, the scores falling within the range. We are going to find out the standard score of those raw scores. Okay. So what we can write? We can write H range standard is a vector equal to scale range. So this is the standard score of the range till 45. And now again, we have to find out the t-score of this. So this is the t-score that we got of the range. Okay. And in the same way, now we have to classify the t-score again. This part is very important and the final part. So please attend it carefully. Okay. So now we are going to classify it again. This one. Classify range equal to classify
Breaks. Equal to C. Bracket with it. There is. C.
C. So we have for the range, we have got the classification as very low, low, like this. Okay. So now if I move on to the interpretation of this thing.
Stop share code.
Hmm?
Stop share code. জিজ্ঞাসা করো ইন্টারপ্রিটেশন এর জন্য দেখা যাচ্ছে দেখা যাচ্ছে
So here you can see the final step in norm construction is classification of the range of total score into different categories, which we just did. Okay. For the achievement data, the lowest score is 9 and the highest score is 45, and therefore the range is 9 to 45. We have to find out the Z score and the T score of the scores belonging in the range. The two score will be again classified into different categories. Now, based on this classification, the norms will be formulated. For example, the T scores ranging from 40 to 45 are classified as high. Therefore, the achievement motivation variable, for the achievement motivation variable, those individuals will be selected who falls in the high 40 to 44 category, which means based on this calculation, based on this calculation, now we are going to classify the range. Okay, so you will see from 40 to 44, those people belong to the high category. Okay, if I show you the and that's not here right now, but from 40 to 44, that those scores belong to the high category, and we are going to select only those people who will score between 40 to 44. Okay, like
interpretation.
Interpretation.
No, তারপরে যেটা এটা বলো।
So those who are high in achievement motivation, they like to be competitive, hardworking, and maintain their performance with a certain standard of excellence. They enjoy performing in tasks where they can get feedback on their performance, and they actively engage in trying to solve the problems encountered. Okay, so the final norm that you will create is based on the classification of the range, classification of the scores belonging to that range. Okay, you have to formulate the norm based on that T score. Okay, not on this one, not the first one. This is classification of T scores, not on this one. After this, you have to find the range, and then you are going to have to find the standard score of the range, the scores belonging to that range from 9 to 45, like 9, 10, 11, 12, till 45. You have to find out the standard score of this. Okay. After that, you again have to find out the T score of this, scores belonging to that range. Okay. Then you have to classify that T score into different categories. And on the basis of this classification, your entire norm will be formulated. Okay. So this is the entire process of norm calculation, and this is the most important part where you have to, the norm that you will finally use will be based on the classification of the raw score, classification of the scores belonging to the range. Okay, from 9 to 45. If there is some other scale, if the range becomes different, like it starts from 20 to and extends till 100, then you have to find out the standard score, T score, and classify the T score of the scores belonging from 20 to 100. Okay, on the basis of that, the scores will be, the norms will be formulated, not on the basis of this T-score. Okay. Have you, like, do you have any question?
Hello, dear students. Is there any question?
No, sir.
Okay, so thank you, everybody. I think everybody has understood very nicely. Ruchira has presented. So, 30 minutes time.
Huh. Acha. After 30 to 45 minutes, you will receive the certificates
In the valedictory session.
in the valedictory session.
In the valedictory, so there will be the valedictory session. At now it is. Okay, so at what time?
3.
Okay, at 3 p.m. we will start the valedictory session. Okay. And I have received only these names. Monalisha Pattanayak, Dr. Dola Mujumdar, Gorima, Shaini, Jyotika, and Dr.
Gaji Ashta, Satyanarayan. So is the norm construction clear? Like, do you have any other questions? Then you are free to ask, because I think this is the most tricky or complicated part.
Okay, so there is a break. So again, we will meet at 3 p.m.
Sir, I do have one question, not exactly related to norm, but since I told you that I'm new to R, and can you share the link of the YouTube? Like it's
Definitely, we'll share. And the valedictory session, we will share that.
okay, so that we can view it again, you know.
Yes, sure. You can work on it. No problem.
Thank you so much, sir.
Thank you.
Okay. So
Okay,
you
so
all,
have this is a coffee time, or you can.
you can take a break and then we'll return at 3. Okay.
Sir, I have one question, sir.
Yes, Monalisha.
Sir, आज one kai $sign parameter. Parameter why you will use, sir? Oh, parameter. One you told me.
Art studio. H1.
H1 parameter, no?
No,
Yes,
H1.
sir. ACH1 kai $sign parameter.
$sign. Parameter. These are degrees of freedom.
Yes, sir. Yes, sir.
Okay, so it indicates the degrees of freedom. Okay.
Yes, sir. Thank you, sir.
Yes.
Okay, so you can come at 3 again. We'll have the small session and then the workshop will be completed. Thank you.